Welcome to Team Magenta's presentation on an overview of systems analysis and design. Team Magenta consists of Ben Pummel, Quincy Grigson, and Devin Grathwall. In this presentation, we will touch on multiple aspects of the systems analysis and design process, along with different methodologies, tools associated with the process, and the methodology that we plan to use during the following projects that are coming along this semester. Let's first touch on the Systems Development Lifecycle, also known as the SDLC. The SDLC is a traditional methodology used to develop, maintain, and replace information systems. It consists of 5 phases. These are planning, analysis, design, implementation, and maintenance.
The first phase to the SDLC is planning. Planning is an organization's total information systems needs are identified, analyzed, prioritized, and arranged. This is where project management begins. You take the input, you do investigations and initiations at the highest level, and create system concepts development. It's also where we're going to use the tool Gantt chart from Microsoft Project for scheduling. Analysis is the second phase of the SDLC. In analysis, system requirements are studied and structured. We gather system requirements, use documentation, and understand our scope, constraints, risks, and cost. The tools used during analysis are DFD diagrams, WBS, meaning work breakdown structure, and BRDs. The third step to the SDLC is design. Design is a description of the recommended solution and is converted into logical, then physical system specifications. There are 2 steps to the design process. There's the logical and the physical design. The logical contains the process view, meaning UML diagrams and activity diagrams. In the data view, or the physical design, we're going to use ERD diagrams, communication sequences, and dimensional models.
The most common misused tools are the UML, activity diagrams, and ERDs. UML, standing for Unified Modeling Language, are a type of modeling language in the field of standardized object-oriented software design. Activity diagrams are graphical representations of workflows, activities, and actions. Activity diagrams can be used to describe the business and operational step-by-step workflows of components in a system. It essentially shows the overall flow of control. ERD, or Entity Relationship Diagrams, are a notational way to describe entities, relationships, and attributes in a database.
The next phase to the SDLC is implementation. In implementation, the information system is coded, tested, installed, and supported in the organization. This can include executing, coding, constructing the system, testing, and installing. Maintenance is the last step to the SDLC. In maintenance, an information system is systematically repaired and improved. This can include maintaining the system, supporting, training, updating and improving, and then also repairing the system. Next, we're going to talk about the methodologies used in systems analysis and design. Methodologies are used to execute a process. Examples include waterfall, case tools, rapid application development, agile methodologies, and extreme programming.
The waterfall approach is where one phase begins when another completes with little backtracking or looping. The pros of this give a high level of control to the developer. On the downside, this gives increased time for development, and system requirements are locked in and cannot be changed. Computer-aided software engineering tools, also known as case tools, will debug your diagrams and generate code based on them. They can assume some roles as programmers. On the positive side, this displays a good look and feel, gives great graphical representations of the system, and keeps everything in a central repository. On the downside, it's very difficult to use with existing systems. Rapid application development, also known as RAD, is a methodology to radically reduce design and implementation time using extensive user involvement prototyping and integrated case tools. The pros of this are that it decreases the design and implementation time. On the downside, it is a very high-cost approach, and it's only meant to be used for large projects, so it's really not useful useful for smaller systems. Agile methodologies are motivated by recognition of software development as fluid, unpredictable, and dynamic. The pros of this approach are that they are adaptive and flexible. The downside is that it requires heavy customer interaction and extreme programming skills. Lastly, extreme programming consists of short incremental development cycles and automated tests. On the plus side, this maintains a constant stream of communication with the developers. It is also a very fast approach. On the downside, it requires a lot of communication with developers who are not necessarily good at communicating with individuals who are not technical.
For our team's approach, we plan on using the structure of the SDLC lifecycle. We also plan on using agile methodologies. We believe that planning is the biggest determinant of a team's success. We also know that communication is key, so we plan on having weekly meetings and using tools like Google and group text messages to have the best communication possible. Team Magenta thanks you for listening to our presentation of systems analysis and design. Here's a list of our citations.